All right, let's go ahead and talk about what we came up with on the table. I filled in column 3 and just wrote out those expressions without exponents. And I think a couple of these you might have, had something different because there are other ways you could write it without exponents. Like some people had 15 times 15 for this, which is true. It's just not going to help you see the pattern that I want you to see with the exponents. So I was nudging you towards writing that. Let's talk about the 4th column here. 3 times 5 squared, I can write as 3 times 5 times 3 times 5. And group 2 asked, can you just rearrange all those factors? Yeah, with multiplication, it doesn't matter what order you multiply in. We'll eventually talk about a name for that. It's just a commutative property. Okay, so I can rearrange all those 3's and 5's however I like. Get the 3's together, the 5's together.
Well, I mean, technically you're just putting the exponent into the parentheses anyway, so you would end up with 3 times 3 times 5.
And that's what I'm hoping you said for your conjecture. Absolutely. If you have a product to an exponent, every factor inside the parentheses is going to get that exponent. Did we say something along those lines for conjecture?
I just said distribute.
Okay, so here's the
So
thing.
much simpler.
You know what, but it's simpler, but it's not technically correct. If I have x times y squared.
So this is another canceling lecture?
Yeah, sort of. Okay, this would be another example of what's going on in B, right? I'm just using x instead of 3 and y instead of 5.
Yeah.
If I've got a product to a power, and I've got parentheses around that, then every factor in parentheses gets that exponent. Okay, but what if I had that? Does that work the same way?
It still disperses the same. You still end up with x squared.
But you have to
It
add
would
plus
be,
y
it's really tempting to, and I like the word you're using, it's really tempting to kind of disperse that exponent, but you can't disperse it like that if these guys are terms. If you have addition or subtraction here, you cannot just stick that exponent on each one of those guys. It doesn't work that way.
Really?
Really.
Why?
Why? And we'll get to this eventually, but as a preview of it, what would x plus y squared, what would that mean literally? What am I squaring?
The
The sum of x and y. So how could I write that without an exponent?
xy squared.
xy squared. Not
How about x plus y times x plus y? Do we agree with that?
right.
Okay. And now, how do I simplify that? And somebody says
FOIL
distributive FOIL, which some of you might remember, and it comes down to distributive. We're not going to go through all the details here, but if you distribute that, you end up with this expression.
And then there's another way to simplify that, but I don't remember.
Okay, we're going to get to all this. This is all coming later in this cycle. But the point is you get this 2xy, and you're going to miss that if you just stick that exponent on each term. Okay, so this is a preview of stuff we haven't gotten to yet, but I don't want you to use the word distribute because distribute is a different idea. Distribute is what you would do with the 2 there. When you multiply it through each term in parentheses, that is distributing.
That's what I.
Okay, but that's not actually what we're doing with the exponents. So it is helpful if you use the right terminology. So in that sense, it is another lecture on canceling.
Is there a more correct term to use for doing that? Like,
So if I
is there
don't
an
want you to
actual
say, if I don't want you to
expression?
say, if I don't want you to say distribute here, what do I want you to say?
Yeah.
You can say disperse, to use his word. That's nice. I just say apply that exponent to each factor. Almost anything other than distribute.
Okay. All right.
All right.
Cancel.
No, that's never the right answer. See, I won't even say that. I'll say classes rescheduled or,
Technically,
Not like cancel.
we didn't reschedule either
I'm gonna
last
send you
class
an email
that
tonight.
canceled.
So I'm gonna say cancel.
Had they been rescheduled, they'd have been tacked somewhere, and we wouldn't have to hustle through that.
you should be writing instead of talking.
Oh, no, we had 2 times to write. You should be writing while we're talking.
And I am. When you have a product to a power, each factor gets the power. Let's say it that way.
There you go.
You could have had something equivalent but slightly different. I'm hoping that you see line C as very similar to line B. Up here I had a product raised to a power. Here I've got a quotient raised to a power. But the game's going to be the same. I can write out that 2/3 squared as 2/3 times 2/3. I can also write it as 2 squared over 3 squared, because when I multiply those fractions, I'm just multiplying the tops, multiplying the bottoms. Okay, so if you have a quotient to a power, the numerator gets the power and the denominator gets it too. So something along those lines. We had a quotient to a power. Numerator and denominator get it. Does anybody have something written that you're wondering is, did you say the same thing in a slightly different way?
Conjecture?
Yeah, for your conjecture.
I just left them all blank. Your definition is a totally different vibe.
You didn't all do that, did you?
No.
But it's good for you to come up with your own and think about it before I tell it to you.
No,
It wasn't
I wrote-
realistic.
What did you write for that?
For 4, I wrote I just put 2/3 squared without the parentheses.
Ah, you're not the only one who did that. So you did,
Wearing only the numerator.
you wrote something like that?
Yeah.
That's a little ambiguous because and you probably purposely wrote this too kind of floating out here.
Yeah.
If you want it to apply to the whole fraction, you have to put the parentheses, or you have to make it clear that that's just on one of them.
Oh, okay.
Okay, so you don't want to do something kind of ambiguous, you know, like that. All right. And plus, it just doesn't help you see the pattern here, which is that the top and bottom are both getting that exponent. Okay. On D, you've got 7 cubed squared. So the squaring means I'm doing 7 cubed times 7 cubed. And for each of those, I can write out 3 factors of 7. And when that's all said and done, I have how many factors of 7?
6.
6.
Multiply the exponents.
Okay, when you have make sure you put when, right? Don't shorten your conjecture down to multiply the exponents, because you want to know when to multiply them.
When it looks like that.
When it looks like that. So when you have a power to another power, an exponent raised to an exponent, that's when you're going to multiply them. I know I'm trying to squeeze these conjectures in a tiny box here. When you have a power to a power, multiply the exponents. Last one, 11 to the 5th over 11 squared. Write out all those 11s and then do what?
Eliminate.
Cancel
Now you're just needling me. I never should have let you know how much that bothers me. When I
Eliminate
slash
11.
those, what am I mathematically doing?
Eliminating them.
They become
That's also
one.
not a mathematical
They
word.
become one.
But it sounds more
It's at least not,
final.
it's
It's
at
way
least
more
not
final.
than canceling. What am I doing mathematically?
Turning them into one, right?
Not canceling, I'm not eliminating, I'm not subtracting.
Simplifying to
Simplifying
zero.
by dividing the top and bottom by 11. I'm dividing off 11s, okay? Because if you're thinking canceling, I would ask you, what's left in the denominator after I cancel?
One.
Why?
Because
that's
you
the way it
divide.
works.
Yeah, see, that's where it falls apart. 11 cubed because 2 pairs of 11s divide off. Okay. Now, some of you said subtracting. There is some subtracting going on, but you're not subtracting the 11s.
Exponent.
You can get to the simplified version by just subtracting the exponents. So I can think 5 minus 2 and come up with that 3. So let's write a complete idea here. When dividing with the same base, you can subtract the exponents. I'm hoping that by going through those in some painstaking detail, they'll stick a little better, because I could have made that way shorter, right? I could have just said, okay, here's 5 exponent rules, but the problem is you'll get them confused, you'll forget them. I'm wanting you to have some ideas that you can go back to on a test. If you forget how this exponent rule works, you can write out all the 11s, you can divide off the pairs, and you can recreate it when you need it. Okay, it's going to stick a lot better that way. All right, flip over. We've played this game a couple of times when we're wondering how something works or why it works the way it does. We look at a pattern. We're going to do that again here. And the goal is to make sense of a 0 exponent. What do you think a 0 exponent is going to indicate?
Multiply it by
So for example, what would 5 to the 0 be?
1.
Why? and if you know that it's 1, or that makes any sense at all, then that's a leg up here, but we want to look at why it's defined that way. Okay, so start at the top of the page, and let's look at that pattern with the 4 to the 4th, 4 cubed, 4 squared. All right, 4 to the 4th is what?
Don't know.
How can you do that mentally? If you want to do a 4th power in your head, you can square something twice. Okay, so what's 4 squared? 16. What's 16 squared?
225.
256?
See, you should do that in your head and
We don't.
well past it.
You're with me on the 4 squared, but not the 16 squared? Okay. 4 cubed. 4 times 4 is 16, times 4, 64. All right, that was a little less painful. 4 squared.
16.
Yay, they're getting easier as we go. 4 to the first, 4. Okay, so the pattern is I'm dropping the exponent by 1, and as I do that, what's happening to my answers?
It's dividing it by
It's
4.
It's dividing by 4, which is a kind of decay, so yay for that.
Yeah, what, applying past stuff.
Okay,
Is
so
that
that's the
exponential
pattern
decay?
here. I'm knocking the exponents down by 1. My answer is getting divided by 4 each time. So I want to know, based on that, what do we think 4 to the 0 is going to be? Because that would be the next step in that chain, right? If I knock the exponent down 1 more, I'd have 0.
Well,
If I
4
take 4 divided by
yeah.
4,
4 is 1.
that supports what you guys were saying. A 0 exponent gives you an answer of 1.
4 degrees equals 0.
So any exponent
Say that again, Sarah.
So every number with an exponent of 0 is 1.
And that's exactly what I want you thinking next. Is there anything magic here about the 4? Could I play this game with the base of 5 or 6 or 7? That's the perfect next thought. Okay, so far we have 4 to the 0 equals 1. All right. Most of the time that's how it's going to work, but not always, which is why your question was perfect. What if I play this game with 0?
Then you
What's
get
0 to the 4th, 0 cubed, 0 squared, 0
It's
to
all
the first?
0.
Those are all zeros.
I thought if you multiply, or if you put
0
0
by
to a
any.
power, it was like undefined or something like
Hold that thought. Hold that thought. Yep. Okay, so based on this pattern, if I go down one more step in the chain, what would I think based on this pattern? What would I expect for 0 to the 0?
0.
Imagine.
But hold on. But based on this pattern, what would I expect?
0.
I would expect it to be 0. Okay? But based on what we were doing up here, I would expect 0 to the 0 to be 1. So it's like there's two conflicting patterns going on. So hold on, let me wrap this. If you take any base and keep knocking the exponent down by 1 and you look at that pattern, it would make sense for something to the 0 to equal 1. So based on that, I would think, okay, 0 to the 0 should be 1. But if I look at a pattern with 0 to all these exponents, then I'm getting the idea that 0 to any power should be 0. I've got two conflicting ideas here. So the question is, how would we define 0 to the 0 then? How do you resolve that?
You make something.
And you hit on it over here. What do?
You
Undefined.
don't. I
You
don't-
basically say we can't do 0 to the 0 because some of the patterns would indicate it's 0, some of the patterns indicate 1, and math is all about making the patterns consistent. So when we have two conflicting ones, we kind of say, well, we can't do it.
So
Or
potentially
there's a
it
new
could change
number.
someday when somebody writes a theory as to how this could work some other way.
Maybe. Try your calculator. What does your calculator give you for
It's
0?
Domain error.
Mine gives me a domain error. Does yours give you some version of that?
Maybe it is both.
It kind of could be
Can't we
either,
just,
but
like,
since
go
we
with
can't
that?
resolve it.
It's kind of like a wave and a particle. It depends on when you look at it. It could be either, but it exists in both. But it kind of exists as neither.
That's not a bad way to put it. Yeah, I wouldn't disagree with that explanation. Here's a mathematical word for it.
Little bit of force Gump.
It's not technically called undefined, although it's kind of like undefined. In math, when it could be this and it could be that, we say it's indeterminate. Basically, I can't determine which it is, so I call it
Are we
indeterminate.
gonna need to know that works for the test?
No, I don't. You know what? That's a good question. I can't remember what my math I will say. It might just say undefined. I'd be thrilled if it says indeterminate, but I think that's unlikely. I want you to know that you can't do 0 to the 0, whatever word you put on it. No, it basically means, here's the idea of how you can make sense of it. If I have 4 squared, it means I'm doing 4 times 4. I'm doing 2 4s. If I have 4 to the 0, it means I'm not multiplying any 4s in, so I'm starting with a base of 1 for multiplication, and I'm not putting any 4s in there. And so I still have a 1. That's one way to think about it. Okay. And we will pick up there on Monday, okay? If you want to